With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, on a platform, a man is watching two trains, one leaving the station, the other approaching the station, both with same velocity as 2 meters per second and blowing their horn with a frequency 480 Hz. The number of beats heard by the man will be velocity of sound in air is 320 meters per second. So here we can say this is suppose the man on the platform, and these are the two trains. One is leaving the platform and other one is, let us say, approaching the platform with same velocity. So here we can say both here are moving with same velocity as 2 meters per second and the man on the platform is at rest. This both trains are, let's say, blowing their horns with same frequency as equal to 480 Hz. Now we need to find the number of beats heard by this man. So the frequency from this first train A to this observer will be our F1, and frequency by this second train B heard by this observer will be F2, and we can say F1 will be greater than F2. We need to find number of beats, that is we need the value of F1 minus F2. Hence by Doppler effect we have here as F1 equal to F0, where F1 is the apparent frequency, F0 is the actual frequency emitted by both these trains as equal to 480. V here is velocity of sound in air, which is equal to 320. VO is velocity of observer and Vs is velocity of source. Since here train A is approaching, so frequency increases, hence this is plus and this part is minus. So F0 here is equal to 480, and here we have as 320 divided by, we can say as 320, velocity of observer is 0 and that of the source is we have as 2. This is plus and this here we have as minus. Hence this comes out to be our F1 equal to, we can say as 480 divided by 318 into, we can say here as 320. Now in similar manner we can calculate this F2 here. So we can say this F2 here will be given by the same formula as F0. F0 here is the actual frequency emitted by this train B here. V here is velocity of sound in air, which is 320, velocity of observer as VO and that of source as Vs. Since train B is leaving here, so the frequency becomes less, hence numerator is minus and denominator we have as plus. So we can say F2 here comes out to be our as 480 into, we can say here this is our 320 and this is also 320. Observer here is at rest and source is, let's say, moving at 2. So this is minus and this we have here as equal to plus. So F2 here comes out to be as 480 into, we have here as 320 divided by, we can say here as 322. So the difference in the frequencies, that is delta F, which is equal to F1 minus F2. So here taking out 480 into 320 as common, so this comes as 1 upon 318 minus this here becomes our 1 upon 322. So this on simplification comes out to be 480 into 320 into, we have here as 4 divided by, in the denominator this is equal to 318 into, we can say here as 322. So this on calculation, let's say we can say this comes out approximately as 6 Hz. So the number of beats heard will be our 6 Hz. So we can say 6, that is option number 1 is the correct answer. So we have 1 as our answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.